All right, welcome to part 2 from section 4.3. We're actually going to look at the second derivative now. We spent a bunch of time looking at the first derivative. The second derivative is going to tell us some cool stuff. It also tells us about max and mins and leveling off, but the second derivative is also about this thing called concavity. Okay, concavity. And I have something that is concave down when it looks like a frown, and something that is concave up when it looks like a cup. All right, let's explore those. So the second derivatives tell us something about what's called concavity. All right, let's look at these two graphs. They're both increasing functions on the intervals A and B. So both of these are increasing functions. Only one of these functions is what we call concave up. Okay, so concave up means it looks like a cup, I was saying before, right? It kind of looks like a smile. Also, the curves lie above the tangent. So if I were to find tangent lines here, the tangent lines are always underneath the curve. If I look at concave down curves, they kind of look like a frown, okay? And all the time, these curves are lying below their tangent. So if I draw the tangents, they're always on top of the curve. So again, concave up, concave down. Let's take a look at what this means. The graph of f is concave up on the interval I if f double prime is positive on I. So concave up means that the second derivative is greater than 0. And then the graph of f is concave down on the interval of I if f double prime is negative. So concave down, if I've got f double prime of x is less than 0. The test for concavity is very similar to the test that we did for increasing, decreasing, and for max and mins. Basically, if the second derivative of x is greater than 0, we know it's concave up, okay? If it's positive, it's up. Okay, if the second derivative is negative, then we know it's down. So if it's negative, it's down. So let's look at this function. Let's first determine the intervals on which f is increasing or decreasing. Now for increasing or decreasing, we always need to use f prime of x, okay? So f prime of x for this function is going to give me 3x squared minus 24x. If I'm looking for its increasing or decreasing, I first need to make sure it's totally simplified and set it equal to 0. And then I'm going to solve it by factoring. And then if I kind of use this, I'm going to use this as my number line here. Here's my x equals 0. Here's my x equals 8. And use some test values in between. This is a nice and spread out problem, right? And then I'm going to plug values into my f prime of x. Remember, I can also plug it into each piece. I can plug it into my 3x and my x minus 8 and look at the cumulative effect. But for this quick example, since we're moving into second derivative, I'm just going to look at the f prime of x. If I plug -1 into f prime of x, I'm going to get a positive number. That means that it is increasing here. And then if I plug 1 into f prime of x, and again, just kind of look at f prime of x or put this in your calculator. You got 3 times 1 minus 8. I'm going to get a positive times a negative. This is going to give me a negative. So this is going to be decreasing. And then at this critical number, here at 8, I've got 0. So I'm going to plug in the number after 8. I'm just going to use 9. So 9 minus 8 is going to give me a positive 1. 3 times 9 is going to give me 27. Multiply those together, I'm going to get a positive number. So this is increasing. All right, so I'm going to say that it's increasing on as x goes from negative infinity to 0, and then from 8 to positive infinity, because these are my critical numbers. And then it's decreasing on that middle interval, okay, as x goes from 0 to 8. Let me fix my notation. That element sign should not look too much like an E. It kind of is an E, but it's a modified E. So in the next part, we're going to look at the intervals on which f is concave up and where it's concave down. And for this, we are going to use the second derivative, or f double prime of x. So remember before, f prime of x was 3x squared minus 24x. I always go with the easier one before I simplified it and factored it, because I don't want to have to use product rule. And then I'm going to take this derivative, and I'm going to get 6x minus 24. All right, so now that I've found f double prime and I've simplified it, I'm going to set it equal to 0. And when I set it equal to 0, then I'm going to look at a sign test for where it's positive and where it's negative. So I'm going to add 24 to both sides. I'm going to divide both sides by 6, and I get x equals 4. So x equals 4 is my only thing. So smaller than 4, pick any number smaller than 4. I tend to always pick 0 if it's available. And then something bigger than 4, and I'm going to pick x equals 5. So these are my test values, and I'm going to plug them into the second derivative. Okay, I'm going to plug them into the second derivative. And that second derivative happens to just be that one piece there of 6x minus 24. So if I plug in 0, I'm going to get negative. All right, and that means it's concave down. So concave down. And then at x equals 5, if I plug that in, I'm going to get a positive number. So that is concave up. So this thing is concave down on the interval as x goes from negative infinity until I get to the critical number 4. And then it is concave up on the interval of 4 to positive infinity. So a point P on the graph F where the curve changes from concave upward to concave downward is what's called an inflection point. So for the function that we just had in example 4, let's find the points of inflection. Okay, so this is where f double prime of x changed signs. So let me just flip back to it. Remember, it changed signs here at 4. So this is an inflection point. So there is an inflection point. At x equals 4. Okay, now it did say that they wanted the point, so I'm thinking I want more than just the x coordinate. So I need to find 4 and plug the 4 into the function so I can figure out what that point is. All right, so I've got the point 4, and then we're going to look at x cubed minus 12x squared minus 2. So 4 cubed minus 12 times 4 squared minus 2. And that gives me negative 130. So that's my inflection point.